Good morning, everyone. You're listening to the Sci-Files, an exposure segment featuring Michigan State University student research. We're your co-hosts, Chelsie
and Daniel Puentes.
Today we welcome Tyler Derr. Tyler, can you please tell us about yourself?
So my name is Tyler Derr, and I'm a fifth-year Ph.D. student in the Computer Science and Engineering Department and a member of the Data Science and Engineering Lab. My research primarily focuses on deep learning on graphs.
Thanks, Tyler. Could you tell us a little bit more about what deep learning is?
Deep learning, Danny, is an area of machine learning that focuses on using artificial neural networks.
And what are artificial neural networks?
So artificial neural networks are an area of machine learning that uses information from neuroscience that tries to harness the concept of how our brains work for learning and predicting things.
And what are you trying to predict?
In deep learning on graphs, we're looking to predict many types of things in graphs, such as graphs contain objects or nodes and vertices which connect them, so relations. And an example of this could be in a social network. We're looking to predict certain attributes or features of a user.
When you say a social network, do you mean like people interacting with each other? Like, can you give me an example of a social network?
So a social network can either be one that's a physical based, or it could also be online. So this could be in a classroom, it could be in a social media application, or things of that nature.
Which particular social networks do you investigate for your thesis?
So in my thesis, I've worked on multiple different types of social networks. So ones that involve trust and distrust, and also ones such as Twitter, which people are primarily familiar with, that involve following and follower relationships.
So then what determines whether a person is to follow someone and whether or not they're going to receive a follow back then?
Currently, I'm working on a new project that is looking to predict not only when someone follows, but also when they unfollow. So primarily people have focused on the follower relationships, but we're looking to uncover these unknown negative relationships.
Are you looking at this within people generally, or within like organizations, or within a certain focus of people on Twitter? For example, Sci-Files is on Twitter at Sci-Files89FM, and we follow students and people here at MSU within the community. So are you looking at people within MSU?
Due to the fact that the data collection started from the Data Science and Engineering Lab, and I follow my lab, of course, and I also follow this radio show. So it would have also been included in the data collection. And we're looking to see that do these follower and unfollower relationships change depending on how important the accounts are, so the users.
How do you use deep learning within this experiment?
Deep learning can come into play where traditionally a lot of the neural network architectures take one specific input and then you get one output. So you can imagine if we took the attributes of a user in a social network and we wanted to predict something about them. But in my research, we look at harnessing the graph level. So can we use the relationships between users to further enhance the predictions?
Can you provide some example attributes that you use in your deep learning algorithm?
So in the social network example, we could use features coming from the text, so the posts that they make. We can also collect things such as their profile information, and in other networks that we can evaluate, such as biological networks, that we can look at information coming, for example, from the proteins.
It seems very complicated to create a network, especially deep learning. What are some challenges that you faced whenever you were creating these networks?
Some of the challenges associated with deep learning on graphs are that we want to balance between aggregating information from our neighborhood, so in the social network example, our friends and followers. But if we aggregate too far out into the graph, that it'll start to get very noisy and we'll be pulling information from users that aren't so similar to us. So we have to strike that balance.
Whenever you say pulling information from other users, are you using other databases?
The way that the graph neural networks work is that traditional deep learning, as I mentioned, takes one input and then it pushes it through an artificial neural network to get one output. And with the graph neural networks, we take one input, which could be a user, but then we aggregate the features from their surrounding neighbors, and then that happens for multiple steps, and for every step, we're going further into the graph.
How are graphs used for neural networks?
So the way that the graph is used is that when looking to predict something about one of the nodes, that we're going to pull information from the related objects. So if you think of in the social network case, to make a better prediction about you, we're going to aggregate the information from your relations, in this case, followers. So we're going to use the information of your followers to better predict things about you.
This reminds me of artificial intelligence, and it has me thinking about Facebook. Like how Facebook will recommend friends that I maybe haven't seen in a while, but also people that I've never even seen before. How does Facebook relate to this with artificial intelligence?
So actually, Facebook seems to devote a lot of resources on this type of research because they are a social network, which means that if they're trying to make better recommendations, that they also want to use this type of technology of the graph neural networks. So more specifically, one direction that I'm currently researching is in the area of privacy. So if we think of on Facebook, we might be able to hide some information from other users, even our friends, for example. But if Facebook's using a graph neural network in the back end, perhaps some information could be leaked.
Using these neural network deep learning algorithms, how could a company like Facebook leak this private information anyways?
One example could be if you've hidden this information from those that are connected to you, or even from, for example, an attacker that had convinced you to make the connection to friend them. But then immediately after you made that connection, if Facebook is using one of these graph neural networks, that your private information could potentially have been used to make recommendations for that attacker, and they could see how these recommendations change when they were connected to you and when they weren't.
I could see this being a really big issue for different things like internet stalkers, for example.
I think so, especially moving forward in the future where privacy seems to be a pretty big concern online.
How can deep learning help protect us from these internet stalkers?
So another direction that the internet stalkers or even other people could be doing is that they might want to figure out if they know who you are on one social media application, who you are in another one.
To help protect ourselves from these attackers, what if we limited the information that we have? For example, what if we don't put that we're in a relationship on Facebook? Would that help?
One direction of research that I'm also working on is that even if someone tries to limit their information or try to hide their identity in a network, that we can actually utilize global information from other users in these networks so that we can map their identity from one network to another.
How do these networks know how to filter through all of this information? For example, back to the Facebook thing, people have multiple things that they're in, like pages and groups and friends, and that's a lot of information.
So the way that the approach that we introduced works is that we represent all this information just mathematically as a vector that represents this user. And then from there, we can use what's called generative adversarial networks, or short GAN, the acronym, and we can use this to effectively map one vector in the space of, for example, Twitter to the space of Facebook. And so then once we've transformed the feature vector of you in one social network to the other one, we can just look for which user in that other network is closest to the transformed vector that we pushed on that side.
Since being on the show, I understood that the vector can have a variety of different meanings. What does a vector mean for your type of research?
In this type of research, you can just think of it as if you represent every user as a list of values, and that list of values can be defined as a vector.
From what I'd gathered from this interview, you've had a multitude of projects. Have all of these been collaborations within MSU, or have you done internships and stuff like that?
So although most of them have been here at Michigan State, I also this past summer had an internship at the HRL Laboratories, which is in Malibu, California, and have established some collaborations with researchers at other universities.
Could you tell us a little bit about the HRL Labs? Is it a private entity or is it under the government?
So HRL Labs is owned by General Motors and Boeing, but they also get a lot of their funding from outside sources, such as the government. So although I would like to talk more about what I had done while I was at HRL, unfortunately, it's something that I can't disclose, that what I worked on.
And that's okay. You are a fifth year graduate student and you have a lot of experience. What are you planning on doing after you get your PhD?
Currently, I've applied and interviewing with universities and seeking an assistant professor position.
What are some of your goals as a faculty member anyways?
Some of my immediate goals are to continue the research directions that I've just talked about and hope to establish better mentoring relationships between graduate students and undergrads, which I hope to do at the new university.
While conducting your research here at Michigan State, have you had the opportunity to mentor students?
Yes, I've had the pleasure of mentoring both undergraduate students and graduate students, and currently I'm a College of Engineering Leadership Fellow and working on establishing a system that can allow graduate students to directly communicate with undergrads about research.
Not many people realize how important fostering that relationship between graduate students and undergraduate students is for the development of an undergraduate student when it comes to their research career. So I appreciate you for making those efforts to, one, try to improve those relationships while you're a graduate student, while then also wanting to pursue and improve them as a faculty member as well. So thank you so much again also for coming today to talk to us about your research, Tyler.
All right. Well, thank you both.
You've been listening to the Sci-Files on Exposure. Thanks for Jeremy Whiting, our general manager, Olivia Mitchell, our station manager, and our program directors, Amber Konitsky and George McNeil. Thank you to all of our listeners that joined us this week. And remember, the truth is in the science. Any comments and questions can be directed to scifiles@impact89fm.org. We'll see you all next week on Sci-Files.